Unit 6 Rational Functions. 6A Graph Rational Functions. Example 1. Graph and find all relevant information.
Thank you, Hillary. Alright, so to find all the relevant information, you are going to factor each numerator and denominator separately. So to do that, you have to look at what you have here. We have 2x squared plus 4x minus 6. To factor that, always think greatest common factor right away. So we have 2 is the greatest common factor. You have x squared n plus 2x minus 3. And that numerator can be factored further. What's underneath the in parentheses? So we have 2 times in parentheses. So the a in this quadratic is 1. So we do what times what is negative 3. They'll add up to 2, and that's positive 3 and negative 1. So x plus 3, x minus 1. You divide that by, well, let's look at the denominator here. No greatest common factor, so you look at, again, the a is 1, so what times what will give me the c, negative 4, that'll add up to 3. And that's x plus 4, x minus 1. So x plus 4, x minus 1. The discontinuities, this is what will make the denominator 0. So discontinuities, what makes the denominator 0? So x plus 4, that factor, what will make it 0? That's negative 4. So x equals negative 4 is a discontinuity, because you cannot divide by a 0 in math. So what can make the second factor equal to 0? X minus 1. What makes that equal to 0? And that's when x equals 1. So negative 4 and 1 are my discontinuities. Now vertical asymptotes. Vertical asymptotes come from looking at your denominator. So we have x plus 4 is a factor and x minus 1 is a factor. The vertical asymptote is going to come from either, it's going to be negative 4 or 1, or it could be both, or neither actually. So what you're going to do is simplify the fraction. The vertical asymptotes is what's left in the denominator. What makes that 0? So x plus 4 is the factor. What makes it 0? Negative 4. Your vertical asymptote is negative 4. So on the graph, we're going to put a vertical asymptote. And the vertical asymptote is a vertical line, imaginary vertical line that your graph cannot go across. Holes are the discontinuities. So like vertical asymptotes and discontinuities can be the same, but the holes are what's left. So negative 4 of the discontinuities was the vertical asymptote. 1 then is the hole. So in the graph, wherever the graph crosses the x equals 1, we'll put a hole there. The holes are also created by the numerator and denominator when they cancel out. This is what is creates a hole in your graph when it comes to the equations. Horizontal asymptotes, let's look at them a little bit further. So horizontal asymptotes, the location of the horizontal asymptote is determined by looking at the degrees of the numerator, which we're going to call n, and the denominator m. So if n is less than m, then y equals 0 is the horizontal asymptote. If n equals m, then the horizontal asymptote is the coefficients, which we'll say is a divided by b. Y equals a divided by b, the ratio of the leading coefficients. And I'll have examples for this so you can understand it a little better. And if the n is greater than m, there is no horizontal asymptote. So what I'm referring to is if you have an equation like f of x equals ax to the n over bx to the m. And there can be other stuff, adding, subtracting along here, but it's all about your biggest exponent. So if the biggest exponent in the numerator is smaller than the biggest exponent in the denominator, then y equals 0. If they're equal to each other, then you take the coefficients in front of those biggest exponents. And if n is greater than m, there's no horizontal asymptote. So going back up, we look at the original equation. So the biggest exponent is 2 in both the numerator and denominator. These are equal, so if they're equal, you take the coefficients, 2 over 1. So your horizontal, which is y, equals 2 over 1, which is 2. The x-intercepts come from the numerator. What will make the factors in the numerator that are left after you simplify will make the factors 0. So x plus 3, when you substitute in for x, that'll make that 0, and it'll be negative 3. So there's x-intercept at negative 3. A horizontal asymptote at 2, let's draw that in. So anywhere along, that is a terrible horizontal line. Anywhere along where y equals 2, that is a line that the graph cannot cross. Now I want to draw in the calculator, or draw in the graph, so I'm going to, the next screen is going to have the calculator on. So okay, so we have this in the graph. Again, if you guys want this calculator, just bring in a thumb drive. So we have a table. And look at some coordinates. I'm looking for some coordinates on here. So negative 2, 1. So negative 2, 1. And negative 5, 4. Negative 6, 3. And once you get the coordinates, as many as you can off the graph, then you just look back at the graph and replicate this, not crossing over any of the x or horizontal or vertical asymptotes. So coming up, go through your coordinates, and once we get to 1, so where x equals 1, we're going to put a hole here. Now your graphs are not going to be perfect, but close enough. And over here, there, and that's your graph. The domain is all real numbers, always. So x is all real numbers. That's an R. For all real numbers, except x cannot equal, and you say the discontinuities where you have a vertical asymptote and the holes. It's negative 4 and 1. Alright, I'm jumping to example 3, just to save some time. Example 2 wasn't really that important. So example 3 here, we have, first thing is the factor, so the numerator is x squared, so the a is 1, so we do what times what is 8, that'll add up to negative 6, and it's negative 4 and negative 2. The denominator is a monomial, don't factor a monomial. So we look at numerators and denominators, nothing to simplify here. Discontinuities, that's what will make the denominator 0. The only factor here is this monomial, 4x. What makes that 0? 0. Vertical asymptotes, there's nothing that simplifies with the numerator, so this discontinuity is a vertical asymptote. And since there's nothing that simplifies with the numerator and denominator, there are no holes. And the horizontal asymptotes, look at your biggest exponent of the numerator, 2, and your biggest exponent of your denominator, 1. And so the numerator's exponent is bigger than the denominator. Let's look back at what we need here. So the numerator's exponent is bigger than the denominator, so the numerator's exponent is bigger than the denominators, so there's no horizontal asymptote. So no horizontal asymptote. No HA. I guess we could draw in the vertical asymptote, but let's look at x-intercepts. Well, we'll make the x, or the, we'll make the numerator 0. The first factor, x minus 4, is going to be 4. The second one is 2. So we'll have x-intercepts at 4 and 2. So put it into the graph. We get to go to the table, find some coordinates off of the table. So we have -4, -3. And it was -2, -3. And more that way. 2, 0, and 4, 0. Those are your x-intercepts. After you get 4 or 5 points, and look at the graph. So this is the way our graph's going to look. It's going to come up here and down, here and down. Remember, we have our vertical asymptote at 0, so we should draw that in. Before you start drawing the actual graph, make sure you have your vertical and horizontal asymptotes in, if there are any. So there's your vertical asymptote. Graphs are not perfect, but they should be pretty close, at least going through the coordinates that are given. So there, comes down. When you draw this on your own paper, it's going to be a lot better. I'm using a tablet here, so it's a little harder for me to draw. Just don't cross over your asymptotes. And you'll be good. So, come to class with any questions. Thanks for listening.